Hello friends, welcome back to another session in which we are clarifying doubts asked by our students. So here is the question. A compound Z with molecular formula C3H9N is reacting with benzene sulfonyl chloride to give you a solid, and it remains insoluble even after adding an alkali. So let's predict that your C3H9N is a primary amine. That means nitrogen is attached only to one carbon. And when this is the case, we react it with benzene sulfonyl chloride. This is your benzene, sulfonyl, and chloride. You can see that this is following the formula C3H9N. So H and Cl have combined to form HCl. Now I'm copy pasting this. या नकल करने में अकल चाहिए, नहीं तो शक्ल बिगड़ जाती है. तो this benzene sulfonyl I've copied as it is. Cl has gone along with H to form HCl. This is getting attached over here. जहां से तोड़ा है वहीं से जोड़ना है, जोड़ना पड़ेगा. So NH, CH2, CH2, CH3. That's what I'll write over here. Okay. Now here we are having an acidic hydrogen. Why is this acidic? Because nitrogen is getting polarized. Nitrogen is getting attracted by one of the world's strongest electron withdrawing groups. Due to this, the nitrogen gets polarized, it pulls electrons from hydrogen, and hydrogen can be released easily. So if I add NaOH, or even if I add any other alkali like KOH, so H will be able to react with OH because this is acidic hydrogen. Neutralization reaction will take place. H and OH will combine to form H2O, and this will get attached over here. So I'll have to rewrite this. Okay, and S double bond O, N, Na. Okay, and CH2, CH2, CH3. So now this has formed a salt, and it is because it is forming a salt, it is very soluble in water. Okay, and because it is very soluble in water, you cannot it does not satisfy the condition, okay, which is given over here, right? It should be insoluble in alkali. Is this insoluble in alkali? No, it is very much soluble in alkali. So after adding alkali, it is soluble. So with the same formula C3H9N, we are now going to take a secondary amine, and let's see whether this secondary amine can react with our benzene sulfonyl chloride and satisfy the condition. What is the condition? Condition is that after adding alkali, it should remain insoluble. It should remain insoluble. It should remain a solid. So here we are taking our benzene sulfonyl chloride, which is obviously the Hinsberg test. So H and Cl will again combine once again to form HCl, and I'll have to rewrite this. So I'll draw the benzene again. Yeah, benzene sulfonyl. Okay, and instead of the Cl, we'll write this N, and this N is attached to an ethyl, CH2, CH3, as well as it is attached to a methyl. So are we having the acidic hydrogen here? Not at all. We are not having the acidic hydrogen here. So if I add NaOH to this, if I add an alkali to this, is it going to react? Not at all. So if it is not going to react, this is a solid, and it is going to remain insoluble even after adding an alkali. So our compound Z is this. C3, count the number of carbons, C3, number of hydrogens, 9, and 1 nitrogen. So, of course, this is the answer. This is Z. And that's it for you. Keep sending more questions, and I'm happy to solve such kind of questions. Thank you.